Welcome, my dear aspirants, towards learning aspects under solid state. As here in this video, you are going to observe the main things about closed packed structures. What is a solid state? The particles in a material matter arranged very closely, and that is leads to rigidity and definite shape. Incompressibility is observed. So this is a piece of check. It is incompressible. If you check water, liquid state, that is possible to compress into ice. So like that, closed packed structures are very important. And then coordination number in solids. Coordination number in solids or crystals. Same word you observed or interacted in coordination compounds. So definition should be clearly given in the question paper as coordination number in solids, coordination number in solids, coordination compounds. So this differentiation should be given at the time of asking question about the term coordination number, as the word is same but meaning is different from towards the situation. Now take down this closed packed structures. Close packing is possible. Yes, in order to understand the three-dimensional view, first of all we go step by step, that is one-dimensional. One-dimensional closed packing. Very simple. How is it happen? Very simple. A particle, as here the particles in the solid assumed as spheres, hard spheres. The particles in the solid assumed as particles in solid assumed as hard spheres. This is very important. Then this is hard sphere, as this is another one. This is one-dimensional linear closed packing, and so on. Here you are going to watch a particular sphere is surrounded by how many nearest neighbors. Suppose if I select this one, it has nearest neighbors we want. It has nearest neighbors. For easy understanding, I would like to give you, these are 5 fingers, closely 5 fingers, nothing but 5 spheres. So this finger, what I selected, is adjacently covered by, attached by how many other fingers? This middle finger is immediately attached to index finger and ring finger, but not directly attached to little finger and thumb. Therefore, this is known as nearest neighbors. Even though many particles are there, 3 left hand side, 4 right hand side, they are not all directly in contact with the selected sphere. So this selected sphere is in contact with sphere 1 and sphere 2. This nearest neighbors of a particle in the crystal, nearest neighbors of a particle or atom in nearest neighbors of a particle in crystal is known as coordination number. This is the definition for board examination. Yes, this is coordination number. Of course, it is not that much visible. I would like to write in a different way. Coordination number. Yes. What is the coordination number in a linear closed packing or one-dimensional closed packing? One-dimensional closed packing. Yes, the coordination number is 2. But we are not describing one dimensional. In order to get the three-dimensional view, we shall go for next arrangement after having one dimensional. Next, two-dimensional 2D. I think you can easily follow. Two-dimensional closed packing. How is it happened? This is one row of particles, second row. This is called depression. This is called depression, and this is in two cases. The particles are arranged like this, and this is a first row of particles, second row, just like the benches in the classroom, one behind the other. So behind this one another particle, this is third one, fourth one, like that. This is known as, what is here resulted? Square shape is resulted. So this is nothing but two-dimensional square closed packing. Two-dimensional square closed packing. Right, select a particle and it is surrounded by how many other spheres? Select a particle. I would like to select this one. Nearest neighbors I want. This is selected. It has nearest neighbors. So I would like to mark some atoms 1, 2, 3, 4, 5, 6, 7, 8. Out of 8 spheres around this selected sphere, how many are direct in contact? That is very, very important. Directly contact. Second one is contact, first one not in contact, third one not in contact, fourth one in contact, sixth one in contact, fifth one not in contact, seventh one not in contact, eighth one in contact. So how many are there? How many are there? 4. So in two-dimensional square closed packing, how is the position of the atoms? That is A. The position of atoms in one row. Second row, exact position A. It is going on in a two-dimensional way, that is called exact position. To me, behind another person, behind that person another one, these are all, many people are stand in a row, that is same direction, position is same, and these gaps are known as interstitial void. The gap among the particles, is known as interstitial void. Okay, so two-dimensional square closed packing, this is coordination number. As the selected particle is attracted by second number, fourth number, sixth number, eighth number. But 1, 3, 5, 7 are not in direct contact, so coordination number is 4. Now, first row of particles like this. Second row of particles are not exactly the same position of first row. This is a depression. That is occupied. This is depression. Like that. Next, this is the depression of this one. Well, depression, how is the position of first row and third row? And so on. Yes. First row and third row, the particle is here, same position. Yes, but second row has different position. This type of arrangement is known as, what is resulted around a particle? Of course, you may extend the drawing. Right. To the selected one, this is selected. Here this is selected. Around this one, sixth one is in contact, fourth one in contact, eighth one in contact, and second one in contact. What are not in contact? 3, 1, 3, 5, 7 number are not in contact. Hence, the coordination number is the number of nearest neighbors of a particle. This is the particle selected. as to this nearest neighbor, how many particles are associated? 4 particles are associated, and this type of arrangement is known as square close packing. 2-dimensional. Here, what is the shape resulted? This is. Then hexagon, 2-dimensional hexagonal close packing. 2-dimensional hexagonal close packing. Yes. Here, what is the result? What is observed? The position of first row particles is not matched with the second row, but the position of first row particles matched with the third row. Therefore, it is AB arrangement. Yes. A sphere is surrounded by how many other spheres? The number of nearest neighbors of a particle in the crystal is called coordination number. Hence, the coordination number is S is particle 1, particle 2, 3, 4, 5, 6. So answer coordination number 6. I hope you followed these two types of 1-dimensional and 2-dimensional close packing. Now come to 3-dimensional close packing. 3-dimensional close packing. After having 2-dimensional close packing, first row, second row, third row, fourth row, these are all linear packing. These are all 2-dimensional. As over this layer, second layer is coming. Then that is a 3-dimensional one, and it is of 2 types. Three-dimensional cubic close packing. Not cubic, square. 3-dimensional square close packing. What is resulted here, students? 2-dimensional. First take down. This is a 2-dimensional arrangement. Yes. Over this you are placing 3-dimensional. Second layer, one more layer, and third layer. This is layer 1. 2-dimensional layer 1. Over that one, second layer. Over that one, third layer. How are the particles in each layer? First layer, particles on, and the second layer on this one, third layer on that one. And how is this information? Yes, this gap is possible to see from one end to another end. The gap, interstitial void. And already this particle is surrounded by particle 1, particle 2, particle 3, particle 4. In this layer, next layer one particle, and another adjacent layer is another particle. So one particle plus another one, total 6 particles are there. So this is A type of, which type of arrangement? A type, 3-dimensional arrangement. Previously, square close packing. And this is what is the meaning of AAA? The position of first layer, position of the particles is first layer, exactly aligned with second layer and all the layers. The position of the particles in all the layers is same, identical, and that is represented by A 3-dimensional. Previously 2-dimensional. And here the coordination number is as already within the layer 4, above the layer 1 and below the layer another one. Total 6 is the answer. You imagine, your imagination is largely help me to make you to understand the concepts in a clear way. Okay, this is about square close packing in 3-dimensional, 2-dimensional into 3-dimensional. This is the final one. Example is polonium is exhibiting this kind of crystal structure, square close packing. And these gaps are possible to see from one end to another end. Why? Because the position of the particles in all the layers is identical. Now come to hexagonal close packing. hexagonal close packing is two-dimensional hexagon placing. Two-dimensional hexagonal close packing is now modified into three-dimensional. As here, what are resulted in this case? Voids are resulted. Voids are resulted. Observe. Yes. If I am joining the particles like this, first row, how is the first row? 1, 2, 3, 4 are in the first row. Second row is in 5 balls. I use 5 balls. And gaps you are watching. See the gap here. The gap here, what you are watching is surrounded by 3 spheres. And that is a triangular void. That is a triangular void. This is first row, second row like this, second row, no. As this is second row and this is third row, then this is a sphere ready to occupy by 6 spheres in hexagonal closed manner. This is 2-dimensional. And 3-dimensional, how is 3-dimensional represented? Very simple. So here observe the particle like this, the middle particle like this, and the adjacent particles are like this. Observe, my dear students. Yes, this is a first row, this is second row, third row, first row, third row. How is the arrangement? A, this is A, first row, second row is B, not identical. This is called depression. This is called depression like this. In the depression, the particle is occupying of this first row. Second row, the depression is occupied by, this is the depression occupied by, and a void is resulted. And here a sphere is surrounded by how many other spheres? 6 spheres. Now this is with repeated by next layer. How is the next layer happened? Next layer is happened like this to cover this one. The particles are covered this one. Yes, observe. Yes, it is a which void? Triangular void. Yes, what is a triangular void? Observe any 3 spheres. Any 3 spheres, if you observe, these are 2 spheres of a row, and this is a sphere in the next row. Row 1, row 2. And this void you are watching, is triangular void. It is a triangular void like this, triangular void. This triangular void is occupying this sphere of the next layer. Then already a gap is here resulted, see. So this triangular void gap is not occupied, some are occupied. So some triangular voids are occupied by the particles like this. Okay, this triangular void, okay, so this triangular void of a layer is occupied by a particle like this, And how is the arrangement of these two? Different. These 2 layers, the particles are not identical, see, they are not identical. The position is not identical, that is. Now, third layer is repeated. In which manner? Yes, like this. Now observe, how is the position? See, this is one layer. This is first layer, second layer, third layer. How is the position of first layer and third layer? First layer and third layer? Same. So that is, and this sphere is surrounded in its layer 6 spheres, and in another adjacent layer 3 spheres, and in another one is 3 spheres. Total how many spheres in 3-dimensional it is occupied? How is it happened? Yes, it is happened by placing like this. It is difficult to show. Like that it is going on. In this case, what happened? All triangular voids are not occupied. All triangular voids. Triangular void 1, triangular void 2, triangular void 3 at present. Suppose, yes, a layer is here forming by covering the particle. Then here, yes. How is this sphere? This void is not occupied by the particle. This void is occupied by the particle of the adjacent layer. So here all the triangular voids are not completely occupied by the particles in the next layer, and it results AB type. AB type 3-dimensional hexagonal close packing. What is the meaning of AB? Observe here. This is A, the position of the particles in a layer. This is B. Both are not matched, different. But C, third layer position of the particle in third layer and first layer. Third layer and first layer, see properly. Third layer and first layer exactly same. See here. Then that is AB type 3-dimensional, previously 2-dimensional hexagonal close packing. The coordination number, yes, within the layer 6 spheres, count it, within the layer 6 spheres, and this sphere is occupied by this one 3 spheres, and this is adjacent layer 3-dimensional adjacent one. Yes, now you are watching this one, and in the book nicely given, and it is drawn like this for your better understanding. Yes. 6 spheres here, a triangle. See the triangle what I am drawing. See the triangle here, and here with the balls, this blue color, 2 red colors, blue color, red color. The position is see here position is same, but here the position is not matched, position of the particle. Then that is here also same way you have to write triangular void. Yes, this is A, this is B, this is C, but same position, so it is A. So the arrangement of third layer particles exactly matched with the first layer, and fourth layer is exactly matched with the second layer, and so on. So such arrangement is called AB 3-dimensional arrangement. And the coordination number, see the coordination number 6 within the layer, 3 adjacent layer, 3 another adjacent layer, below and above. So answer is 12. I hope you followed this one. Little bit dry area, better to follow, my dear. See the arrangement here. Here the arrangement what I am showing like this, correct? What I am showing is like this, dear students. Clear? This is called triangular void. What I am showing, yes, triangular voids not exactly, all triangular voids not exactly covered by next layer. Some are occupied, some are not occupied. If occupied, what happened? Yes, this triangular void is occupied by another particle, only one particle. See, this triangular void is occupied by this particle, and that void becomes, yes, next VOI, DS. Voids is our next topic, will be discussed after having one more structure. Yes, very close. That is, are you followed this one? AB, and AB, and so on. This is the arrangement. Say two particles at the top, one particle bottom, two top, one bottom. That is same arrangement of the particles. Now, what is here happened? Here a different story, repeated one is a different story. I would like to show. Yes, this is the arrangement of particles in one layer, and that is occupied by, yes, this one is occupied by a sphere. Over. Now, here what happened? Third layer. Yes, this is first layer, and now it is very clear. This is first layer, dear students, two particles, and this is second layer, and this is third layer. How is the first layer, second layer? The position of the particles not matched. And third layer is not matched with the second layer as well as first layer. And fourth layer, if you take fourth layer, how is the fourth layer? Fourth layer is repeated like this. Fourth layer is repeated like this. Okay. Then fourth layer is exactly matched with the position of the first layer, and this arrangement is called three-dimensional cubic close stacking. Is resulted in what way? As this is the arrangement of particles in a layer like hexagon, correct? Like hexagon, and this particle is covering a triangular void of this one. This is covered like this. I would like to show once again. Yes, like this. See, this triangle what I drawn, first layer is covered. This one. Okay. Now, third layer is coming. First layer over second layer over third layer. Third layer is like this. Third layer is like this. Now observe, how is the arrangement? The particles, position of the particles first layer is matched with, is it matched with the second layer? No. Second layer, is it matched with third layer? Sorry, third layer, is it matched with second layer? No. Or first layer? No. So therefore, A, B, C, three different positions of the particles in three layers. Fourth layer in the same way. Fourth layer in the same way. Fifth, sixth, and so on. Fifth is with the second one. Sixth is with third one. So this type of arrangement is called A, B, C, A, B, C, A, B, C. Here, one particle top, two particles bottom, and this is A, B, C. Now A, how is A? A is like this. A is like this. These two I would like to show, my dear students. These two, you just cooperate. As this is one particle top, two particles bottom. One particle top, two particles bottom, and this is two particles top, one particle bottom. Both are matched like this. Over like this. Then what happened? Are you watching the gap from my side to your side? The gap is not completely occupied by the particles, one layer with the other layer. Still gap is maintaining. As this gap is known as octahedral void. These are the three particles. What I showed, three particles triangle. Two particles top, one particle bottom. One particle top, two particles bottom. How is the gap? See, the gap is still maintaining. I would like to draw in a different way. Yes. And what is the shape you are observing? I am holding which colored balls? Red colored balls, and as blue color above the plane, and this is below the plane. How is the shape? The shape is like this. Shape is like this. Corner 1, corner 2, corner 3, corner 4, above the plane, below the plane. The shape is octahedron. See here, above the plane, below the plane, above the plane, below the plane. Okay, little bit. Yes. Now you are watching red color in my fingers, within my fingers, and this blue color ball is above and below the plane, and these are octahedral void. This void is called octahedral void, and this void is surrounded by a void of the layer. See here, it is surrounded. Now this void is not possible to see from this end. It is covered by the sphere, center sphere of this another layer, and this void is called a void. This is a triangular void covered by fourth one, that is tetrahedral void. Tetrahedral void. Yes. In addition to this, what are regular voids? Triangular voids. So this is the information. Here also, what is the coordination number? What is the coordination number, dear friends? Here this sphere is surrounded by 6 spheres, and this sphere is in contact with these 3 spheres, correct? So 9, 6 plus 3, 9, and here it is 3. Now, how is the arrangement? A, B, C, not matched. A, B, C. This is not matched with the position of this one, and 12. Again, the coordination number is 12. I hope you followed this information, and types of voids will be drawn once again clearly.